First, I just want to say thank you for coming and joining this session today. There's a lot of great content that's going on right this very moment, and the fact that you've chosen to be here means a lot. So I think we're going to have a discussion where we'll learn a lot. You'll have things that you can take back with you to your organization to apply within damage prevention, but also maybe in other places as well. And so the conversation today is around the CGA's 50 and 5 and what Earth Solution does to help realize that goal. And so today we're going to talk about that challenge. It is a challenge, right? And then we're going to lead into the blueprint, how we can deliver impactful AI. A lot of people are doing a lot of different things with AI, and what we have discovered through our own experience is how to deliver that impactfully and to do that repeatedly and do that well. Next, we'll go into the playbook and how we leverage that AI that's been delivered to develop a playbook that realizes that 50 and 5 goal. We'll cover a little bit of how we do that. In other words, we'll look into how data helps drive these outcomes that can allow us to achieve that goal. And we'll have at least 5 minutes at the end for a little bit of Q&A. I do want to say this is also being live streamed thanks to my friend Jason Adams there in the back. It will be posted on YouTube afterwards, so if you do want to share this presentation with anybody, your colleagues, friends, you can do that via the Earth Solutions YouTube channel. So, the 50 and 5. It's quite the challenge. I think this is the 4th year into it, and we have seen it is not easy, right? And so let's talk about why that is. And I think we could all sit here and discuss and argue over a lot of different reasons why this is hard. But I'd like to assert that it boils down to 2 major things. The first is scale. This is a high-scale problem. There are over 100 million excavations per year. If you do the math, that's 3 new excavations that begin every second. That includes business hours, that includes nighttime, that includes weekends and holidays. In fact, by the time I'm done giving this presentation, more than 10,000 new excavation jobs will have started. And also, many incidents will have occurred. The second problem is scarcity. Show of hands. How many people here have the resources, have the budget, the people, and the tools they feel they need to accomplish the CGA's 50 and 5 and reduce damages by 50%? There's not a single hand up. So at this scale and with this scarcity of resources, the strategy emerges. The real job here is prioritization under uncertainty. Enter machine learning. ML solves these problems. They solve problems at scale that have scarcity and require prioritization as a strategy. It ranks millions, tens of millions of tickets by risk and identifies that risk quite well. It is very good at anomaly detection. With the hundreds of millions of data records and humans poring over that vast data set, it's impossible to identify trends in the data by hand. But machines can do it. And they can do it at scale. Finally, continuous learning. This is not a one and done. This is not a, we're going to deliver this workflow and things are going to be better and it's just going to work from here on out. It requires continuous learning. It requires a commitment to continue improving. And this is also something that machines are very good at. 95% of AI pilots fail. This slide has nothing to do with aviation. MIT last year released a study that looked at hundreds of different AI pilots that were delivered into production, and they found that the vast majority of them were not successful. They then went into the reasons why that was the case. And I'll give you a spoiler, it's not because the technology doesn't work. Here are the reasons, at least 4 of them. There's a lack of leadership alignment. There's a lack of buy-in from the executive teams or the managers. There's no clear goals. Nobody sets, this is the goal that we're trying to achieve. There's no ownership to drive behavioral changes, deliver training that comes from these predictions. And there's no way to measure value. If you can't do that, then you can't prove whether or not you were successful or not, and whether you're on the right path. We'll get into more, all 4 of these points a little bit more as we go through this presentation. So delivery is not enough. Again, you can't just deliver a model, a prediction, a workflow, and expect it to work. It's an operating loop. We take the things, the predictive analytics, and we use those to make informed decisions. And we use that to drive action. And from there, we measure the results of those actions, and we use those results to improve. And we do this over and over and over again. So, what does a repeatable, measurable AI launch actually look like? This is what I'm here to tell you, and this is what Zank is here to tell you. But first, I want to show you what's on the other side. I want to show you that what can be possible if we do this, and what is possible because we have done this. This is a result we just got in about a week before I submitted this presentation. We're in the process of formalizing it. But the success has been measured, and it's significant. We have a large US communications company, Fortune 1000, services over 20 states, has high scale, 4.5 million tickets per year. And we automated one of the workflows in that organization for damage prevention. Due to that automation, tickets that were touched by this workflow, this improved workflow, were 83% less likely to result in a damage than tickets that were not touched by this workflow. Very significant result. And by the way, they also saved over $2 million in Q1 alone. They're on track to do $9 million this year. I think they'll actually make it to 10. This provides a unique opportunity to reinvest those savings back into your damage prevention process to further drive down damages. And by further driving down damages, we save even more money, and we can reinvest that. And all of this amounts to our goal as an industry, preventing damages, improving public safety, and increasing asset resilience. A couple of more additional proof points. We have implemented AI workflows at Brightspeed for double-digit damage reduction, fast payback, stake center locating, significant field efficiency gains by leveraging automated workflows, and also augmented workflows where machines provide information that allow better human decisions. And finally, our friends at Colorado Springs. I figure this is pretty relevant. The utilities here in the city of Colorado Springs, we implemented workflows and reduced damages by more than 17%. There's one more I want to talk about that's not on this slide. It's for NiSource Gas Company. We worked with them to identify incidents that would qualify as critical safety incidents. What that means is incidents that will result in evacuations, property damage, or injury or death. By leveraging and working through this blueprint that we're about to share, we were able to improve their ability to predict these critical safety events by 290%, or almost 3x. So I mentioned earlier about this blueprint. I'd like to invite my colleague, Zank Bennett, to the stage to explain this. And one of the reasons I'd like him to explain is because, as I mentioned, this is not specific to Earth. It's not specific to damage prevention. This can be applied in any organization for any reason. And so Zank has done that successfully here at Earth. He's also done it for industries like consumer product goods, finance, PE, and a few others that he'll probably talk to you about. So, Zank.
Thanks, Kyle. So as Kyle said, this is an honor and a privilege anytime I get someone's attention, and to have this many people's attention is certainly both of those. So thank you so much. And it's always fun to get to share a stage with Kyle, who's a colleague and who's become a friend over the years. I'm going to talk about this blueprint, right? In text on the screen, it says, Earth's repeatable path to AI that works. Somebody tell me what works means to you. Anyone? When I say this, you have a feeling, right? AI that works. What does that mean? Is there an adjective? Is it friendly? Is it descriptive? Is it repeatable? Is it reliable? Is it timely? Is it competent? Is it positive? Yeah. I sat there at lunch and was blown away by the pictures of those homes, and that wasn't a pun at all. I can't wait to put some of those pictures in front of our team. I'm not sure that they've seen them. AI that works helps prevent those things from happening. They have to be reliable, they have to be timely, they have to be believable, understandable, all of those things. And for 27 and change years, I've built a blueprint for delivering exactly that, and that's what I'm going to share with you here today. So this is it. It's 7 steps, and then my most favorite, I guess, is that okay to say? My favorite, the showcase at the very end. Let me just go quickly through this list, and then we'll dive into each one in a bit more detail. So first is the use case. We've got to figure out what we want to do, right? So maybe that's prevent damages. That sounds like a good idea. It sounds like a use case. Maybe we're going to want to refine that a bit. I'll get into that. And then we need executive buy-in. Kyle mentioned that earlier, right? I'll talk about how important that is. And then objectives. Objectives are the things we measure, and it's so easy to get that wrong. And I'll give you an example from another industry. We can have some fun talking about that. And then the data, right? I don't need to introduce data. Years ago I used to. Now everybody knows how important that is. And then we have a spike. This isn't just what we're saying on this slide. It's not just a blueprint item. Kyle and I have them in the Gantt chart. We have spikes labeled out. They're very, very important events, and I'll define that. And then we get small wins. Why small? I'll talk about why small matters before we scale. It was really fun early in my career. Oh, that looks promising. Let's just go straight to the finish line, raise our hands, cross the tape. I think we won the race, and then you realize that you're a day late. Everyone finished the day before. And then how do we build to grow maturely, right? And then finally, showcase. My favorite, and we'll get to that at the very end. So the AI blueprint in a bit more detail. The use case, right? This has got to be timely, so don't spend too much time here, or else the engineering axiom that I learned in college will come true. And that is, if it's still working, we haven't added enough features. Everybody knows that one, right? Yeah. And we've got to be succinct. So if we don't give ourselves too much time, we won't get carried away. Everyone's guilty of that, I think. So use case, pick something very specific. Kyle put a few examples on this slide for us to look at. Let's get right on to executive buy-in. This is my 28th year of practicing this in this field. I was a research engineer for a long time, and then I became a data scientist, a director of engineering, all these different things. I don't know what my title is anymore. But suffice it to say that I've never seen a project in my life succeed where a buy-in didn't come from the top. But who cares? I'm a study of one, right? Maybe someone's saying out there, well, I didn't get buy-in, I did great. We're doing a whole lot and I didn't have any buy-in at all. Okay, well, why would I say I've never seen it, right? Can you all think about why it would be absolutely important to have executive buy-in for a big analytics project? I'm going to bring up an example within Irth, the sales team. Sales has to know exactly what we're doing. This conversation we're having today, I hope it's at a level that I hope a kid could walk in, 12, 13 years old, and say, I get what he's talking about. That is my bar. I want to make things so simple. And so when I reach out to a sales team, and Jason's in the back, I appreciate him so much. He's taught me so much. If I can communicate to salespeople about why what we're doing is so important, then that sales team can reach out to our customers and say, hey, this is really, really important. So it's not just sales, it's, hey, we've got this thing that we can help you change your business. That's executive buy-in. I probably spent too much time already. I've got to get through a few more things. Objectives. This is the thing that we're going to measure to say we did good. I was at Trunk Club for a while. It was a Nordstrom company. We sold boxes of clothes. We sent them out in trunks. You guys know Stitch Fix, the Trunk Club? People have heard of this, right? Yeah, it was nice clothes. Okay, so what's the objective of that company? I'll tell you a little bit about it, and you can imagine the thing we want to measure, the thing we want to maximize or minimize, right? So we want to minimize damage. At Trunk Club, we were maximizing something. So we send a trunk in the mail, right? Imagine yourself opening up this trunk. There's 10 items in there. You try 8 on, they're great. And the last 2, not so much. So you put them back in with the label, and you send it away. Cool. So now I'm sitting there at Trunk Club going, I wonder what happened today. So I open up my laptop and look at the data, and I say, well, we had an 80% keep rate, right? Keep rate. Open up a trunk, keep 8 items, send 2 back, 80% keep rate. So what are we going to optimize for at Trunk Club? Maximize keep rate, right? Makes sense. Wrong. We were wrong. So I went to Terry Boyle, the CEO, and I said, Terry, I don't think that's the right thing to optimize for. And he said, no, it's not. So what is the right thing? Anyone know? Okay, you open up a trunk, right? And just picture a woman, and she opens up a Madewell t-shirt. That was a very popular item. And she puts it on, and we got the size right, thank goodness, because that was hard. And she says, I love it, I'm going to keep it. And so she keeps it. And then she has a dress that she ordered for a special event. She puts it on, and her mom's visiting. And she goes and sees her mom in the other room, and her mom tears up. Holy wow. Now, we didn't have any sensors in these trunks. Of course we didn't. We had no way of knowing that we almost toppled this woman over with one word, delight. So what was the objective function of Trunk Club? Maximize delight. Brings me to the next subject, data. We didn't have delight data on the menu, did we? There wasn't a little, I don't know, anything in that box that could have measured delight. We didn't have a horripilation sensor, whatever you might call that thing that measures goosebumps. Couldn't do it, so we didn't know. So we did the next best thing we could. At Irth, we're looking at reducing damages. We're looking at tickets that come in and saying, is it going to be an incident in the future? Very easy for us to define, very easy for us to see it in the data. But to make this blueprint general, I wanted to bring up these cases where the objective isn't always obvious. And another thing that's really important when you're doing this is in that number 3, when you're having an objectives conversation, have it as high level as you can. Allow people to use adjectives. Allow people to get creative, allow people to care, to lean in, to raise their voices. That's when data professionals can understand what really matters. And it wasn't keep rate. It is those homes we saw right next door. That's what I want to hear in an objectives meeting. Spike, go, no go feasibility test. Why would we do this? This is the first time the data hits the computer. So it's guys with the big glasses and women with the tape in the middle, and we're sitting there in a dark room just 4 inches from the screen staring at it. And if we get some good results, it's a positive spike. If we don't, we come back, we ask some questions, but we get here fairly quickly. We don't want to go on and build things. So the spike is really important. And then we go through small wins. A small win in damages, we might look at a demographic and say, well, there's enough exposure on the data side there for us to get some real traction. So we might expose our algorithm and say, hey, based on these tickets, this population of tickets is going to be high risk. Let's flag those. Let's do something about that, right? That's what we do in a small win. If that works, we go bigger. We go state, then we go country, then we go North America, which is what we've done. At Irth, we have more than 70 models in production, aiming for up to 100 at the end of the year, which brings me into the next subject, build to grow. I went to the University of California in San Diego. I spent almost a decade there learning. And I would walk by, and I just went last week to visit it because I've been down in San Diego recently, and it was fun. And they still have these columns. They were much taller when I was an undergraduate. I don't know why that works that way. They were as tall as buildings, but now they're maybe 20 feet tall. And of course, it's just my perception. But they have lines on them, and students go out and they write what the line meant. There's a big crack. What caused that crack? Well, they have a seismic, I don't know, we call it the shake lab. And so the engineers would go and they'd shake these giant columns and figure out how to inform Caltrans to retrofit all the bridges in California so when they shook, they didn't fall. When the work that Kyle and I put together, when it gets shaken, when things change, when regulations change, when the way people are doing things change, when these locate wands, and I'd never seen one in person until today, I was pretty excited. When those come on the scene, we're able to increase our accuracy. What does that do to our training data, to our algorithms, to how we represent and look at risk? It changes things. We better darn well have a good pipeline, so when we put new data through it, nothing breaks, and we can still support our customers at the scale we're at, which is quite impressive. That's why this is so, so, so important. And then we get to showcase. This is my favorite part. If we do this right, we sell the whole way through this path. I'm a salesperson. I'm trying to sell you guys this blueprint right now. I'm super excited. If you can't tell, I love this stuff. So you can probably read my energy, right? How do we do that? How do we do that as data professionals? We create a great demo. Claude came out with a tool 2 weeks ago. When I say 2 weeks ago, it sounds impressive. It's not that impressive because, of course, ChatGPT came out with one last week to make incredible visualizations. So type in your idea, prompting, get a great output out. Take those houses, put them in there, and say, look, here's what a bunch of tickets look like coming through our system. We could automate this. We could flag some and say, and then put this in front of a senior executive in step 2 and say, this is my dream. We're going to do this. We're going to go build it. And it motivates everything all the way through. That is the blueprint. And I'm all done, and I want to thank you for your attention. I'm going to pass this back to Kyle to talk about how we've used this blueprint to help all sorts of areas in Irth and help protect a lot of people. I love talking about this stuff. I'm very passionate about it. My name is Zank. If you want to, please find me. I'm around, and again, always love to talk about this stuff with all of you. Kyle.
Thank you.
Thanks.
Thank you. So now we have this playbook. We've run through this more than 70 times at Irth, and Zank has done it plenty more as well. And so how do we use that? So we have this impactful AI that's been delivered, and we want to achieve this 50 in 5. And that is through a playbook. So let's look at the math again. Incidents, damages occur on about a 1 in 1,000 basis. Given the scarcity that we discussed earlier, you can't treat all of them equally. If we had the resources we needed, we could give the attention that we wanted to all of them, but we don't. And so AI's job is to rank those tickets, rank those excavations in the order in which we believe the model has learned will result in an incident, has the highest likelihood or the highest impact should an incident occur. We want to subject the lowest risk tickets to that scarcity, right? If we have to have scarcity somewhere, it should be for the lowest risk tickets. We should not subject the high risk tickets to that scarcity. And the outcome is the one that we set forth at the beginning. Fewer damages with the same amount of resources under the same level of scarcity. So the operating model. We provide predictions for a lot of things, but the one that's important now is incident likelihood and incident impact. And so we use that to formulate our playbook. And so if you're looking at, if there's any football fans in the room, you have your quarterback that's on the field. He's got his playbook right here on his arm, and he's looking at it. He sees kind of the personnel that's come into the game on the defense, and he looks and he says, okay, in this situation, what's the best play that's going to have the highest likelihood of resulting in success? Maybe it's a fade route, maybe it's a pass to the flats, maybe it's play action fake, something like that. Here, our playbook is interventions and automations. So we can automate a lot of these mitigations, these things that we hope by intervening will reduce that risk. That could be automated proactive outreach, emails sent to excavators, text messages, even personalized phone calls, doing things like QA audit checks in the field after the locates occurred, doing photo audits on the work that's occurred in the field, even so far as standbys or watch and protects for the highest risk tickets, and perhaps those that have the highest impact potential around high impact pipelines and things like that. And then again, measuring and improving. As you call those plays, how successful were they, right? So if I'm a quarterback and I'm running play action, was it successful? Did we get the first down? Did we get the touchdown? What have you? It's important to measure these things at scale. So now the proof. I'm going to talk a little bit about how we do this with the data that we have at our disposal. And so Irth has a very robust data set in terms of both breadth and depth. We have Irth touches more locate requests than any organization on Earth, pun not intended. We also have a lot of data around geohazards, climate, weather, land-based imagery, and several other adjacent verticals to damage prevention. So what do, we take that data, we correlate it, we identify patterns, and we deliver insights. And so here you see just 4 of the major insights that we deliver: risk and safety, which is what we're talking about here. We also provide insights around asset integrity, operational efficiency, quality, and more. And again, the depth and the breadth of our data allows us to do this very well. So on the left, we have our data sources. On the right, we have the insights. How do we translate? How does that translation take place, right? How will you turn data into actionable insights? Anybody? I'll give you a guess. Zank, you cannot answer? It's the blueprint. It's use case, executive buy-in, determining the desired objectives, looking at our data, running an experimental spike, finding if we have that predictive signal in the data, and if we do, we proceed. If we don't, we ask questions to try to find it, or we fail fast. We look at small wins, we deliver those small wins, build to grow and showcase. And so, as of today, for damage prevention, Irth Insights has 3 main offerings. We're working on several others right now, but this is what we have today in production. We have, and I'll go through each one of these a little bit. So, first and most relevant, I think, is risk insights. This is how to prevent incidents from occurring, and also focusing on preventing the largest impact incidents. And so you'll notice here on this slide, you see the use case at the top, you see the objective as the second bullet, you see the data as the third. Again, this follows that blueprint. So you see the use case objective. This model was trained on tens of millions of tickets and tens of thousands of incidents. And the graph on the right represents those tickets and those incidents. So if you look at the x-axis, you have the ticket, all of those tickets ranked in order from the highest risk ticket on the left to the second highest risk, to the third highest risk, to the fourth, all the way down to the right side of the x-axis, which is the lowest risk. And we look and we say, okay, how many incidents can we capture in the highest slice of risky tickets? And that's highlighted in the red here. We can predict 50% of incidents in 8% of excavations. So if you're talking, if you have, let's say, for round number's sake, 100,000 tickets, we can say these 8,000 are going to result in half of your damages. Not only that, we can tell you where the risk is not. We can isolate 9% of incidents in a quarter of your tickets. So, 250, or 25,000 of those tickets will result in only 9% of your incidents. So what do we do here? We have an opportunity to direct our resources where they're going to be most effective. We should not subject the low-risk tickets to scarcity. We should instead focus those resources on the tickets where there's high risk. And this is how we can reduce damages. We provide screening insights. This allows us to automate the dispatch of tickets to the field. And this allows us to use our scarce resources, which might be our field locators, our screening and dispatch personnel, and so on, to focus on the segment of tickets that need human decision. So they can do a better job at making the decisions that they need to make, and they're not distracted by obvious noise, things that obviously need to be dispatched or can obviously be cleared. So higher quality human decisions and automation where we have enough confidence. Let's talk a little bit more about measuring. So we have these things called what-if analyses. And it allows you to ask questions like, what if I had done this last month? What would that have looked like? So I can say, if I automated this play or set this automation threshold to this value in the month of March, what would March have looked like? And it can tell you, you would have been able to auto-dispatch this many tickets, auto-clear this many tickets, you would have incurred this many less damages. And so you can tune your playbook and the plays that you are running in your damage prevention organization to meet your needs. And you can do that confidently because you know, based on recent past, what that would have looked like if you had been running those plays. The last type of insights that we provide in damage prevention today are photo vision insights. This allows the automation of quality assurance. It allows us to analyze the entirety of the work being done in the field. Right now, a lot of organizations, they either pick at random tickets to do office audits or review the photos on, and they only get to a few % of them, right? So what we can do here is we can automate that process. So 100% of the photos attached to locate requests are analyzed and ensured that they meet the criteria and the quality standard that you have set forth. It ensures that the work was done in the area that it was supposed to. It ensures the work was done at the time that it was supposed to be done. It ensures that marks or flags or the appropriate field actions have been taken at the job site. And obviously this reduces the amount of time spent by humans reviewing this. We can escalate situations that aren't quite sure of or that failed the audit to humans for a more thorough review or corrective action, right? So What's next? So we're looking at doing some insights around ticket effort and cost. And again, so this particular project is currently in the spike phase. So we are actively experimenting with the data that we have. We have the use cases and objectives set here. And this is what we're trying to achieve. We're trying to achieve on-time compliance by allowing the intelligent allocation of work to field locators, making sure nobody's too overcommitted or overloaded. So we can do that kind of load balancing mechanism, and we can do it automatically. You can weigh risk versus reward. So you can see, hey, this is a high effort ticket. This is the risk involved with that ticket, and make business decisions based on that. We can also predict what the, not only the effort, but also the cost is on completing a locate request. So we'll have some preliminary results here on this in the next few weeks. The next thing we're looking at is excavation scope insights. This is something that we are just about to start the spike on. We have set the use case, we have set the objectives, we have executive buy-in, and the idea here is to provide guidance on where the excavator intends to break ground. And so what you're looking at here is a locate request. You can see the bounding box that's sent out by the call center. But you notice in the ticket text that they are locating a 15-foot radius around an existing fire hydrant in front of the property. Now, in the red, that's more than 15-foot radius, right? That's almost an entire city block. And so knowing that, hey, the scope of this work is actually significantly less than what the scope of the call center has set forth can be very useful. It can be useful in driving in more intelligence decisions for screening. It can also provide better insights for risk, because if you have a high pressure pipeline or a gas main in the left area of the red box there, but you know the excavation is taking place on the other side of that red box, in the blue box, in the blue circle, that can inform your decisions. And again, we can use the resources that we do have to the best of our ability by not sending somebody out to this site, because we know that the excavation is not going to impact the assets that we have. So the last thing I wanted to touch on before we close is what we refer to as a private preview program for design partners. And we're looking for ideas from you. We want to take your idea from concept to outcomes. Several of our models, again, we run through this blueprint, were a result of people coming to us and saying, I think we can do something here. I think we can achieve something. I have an idea that for an outcome that I think we can achieve using the data that we have. And so what we're looking for are design partners, people who can help commit, have executive buy-in, and take that, again, that concept to reality and deliver those outcomes. The benefits here are early access, faster time to value, and involvement in a tight feedback loop that ensures a real-world fit and real-world success. And so, if you have these ideas, please get in touch with one of us. I'll point out Bill. Bill Wag is our solutions engineer at Irth Solutions. Can you stand up just for a second? And if you have an idea that you want to talk about, by all means, find us. We're happy to talk to you about it. It excites us. It's something that we really enjoy. So I'd like to start closing, but before we get to Q&A, I wanted to just kind of recap the key takeaways. CGA's 50 and 5 is hard. It's really hard. Insights enable outcomes that get us to that goal, but it takes actions to realize that outcome. Automating, intervening, and measuring is the path towards realizing this goal. And Irth is positioned. We're happy to partner with folks who have ideas on how we can get there. And we have the data, the expertise, the tribal knowledge, the industry knowledge to make that happen. So I'd like to open it up for Q&A. If you have ideas, questions.
Hey there. Great presentation. Thank you very much for doing it. This is Tim Spade from CGA. We are about to launch a study into what I'm calling rapid no-conflict responses, i.e. screening software.
Mm-hmm.
We're aware that a lot of operators are using it, various tools. And what we're looking at exploring is the potential relationship between that process and potential issues downstream, such as clear evidence being observed on site, notifying us of, with a 3-hour notice. Is there a relationship between that initial screening and perhaps the damage that's later cleared via an emergency ticket? And so I guess my question is, you mentioned one of the tools you all have, I believe one of the models is sort of used for that purpose, screening.
Mm-hmm.
Is there any concern that the screening of tickets, by its very nature, is possibly contributing, or I guess contributing to increased incident likelihood?
Great question. So that is one of the concerns that we had from the get-go, right? And so one of the things that we set forth immediately upon that process is looking at, that was one of the outcomes, one of the things that we were going to measure, right? And so I'm happy to report that in all of our implementations of the screening model, the tickets that were screened by AI have the lowest incident rate of any cohort of ticket. In other words, and also we see an overall reduction in incident rate as a result pre and post of that implementation. Great question. Oh. I'm gonna make.
So just building on that. Yeah, I don't think I need a microphone. So building on that same question, but I like that if you go back a couple slides to the Polygon example where you used AI. This seems to work really good with the extreme example, right? 15 feet around the fire hydrant, AI is able to pick that up. Screening is an issue, not just an incidence, but it's actually increasing ticket volume when excavators go out and find out that things have been inappropriately screened. So has a company ever looked at using AI in the reverse? In this extreme, let's say this ticket was incorrectly screened out. Could you have an AI model that says, no, there actually is company facilities there because there is clear evidence based on mapping data.
Mm-hmm.
A check and a balance. Because right now AI is very good at screening out tickets.
Mm-hmm.
And what we're seeing in the real world in Virginia is actually it's creating more challenge tickets, what we call 3-hour tickets. So have you experimented with that at all?
Yeah, absolutely. And that, again, great question. When we look at, screening, there's a lot of inputs involved. The ticket's one of them. we can also consider GIS data provided we have that, right? And so we could put a hard stop on, say, anything that's within a certain proximity, anything that's of high value, right? Like a high consequence utility. That is all configurable as kind of a stopgap. The other thing that comes about, which is related to that, is new build, right? So the model historically doesn't know that there's something that just got installed, right, last week. And so there are ways to address that via, as an example, looking at the install date in your GIS data to say, okay, this was installed recently, the model, you don't know about this yet, right? So don't even invoke the model. Don't invoke the automation around this area, right? And so those are ways to address those concerns. Does that answer your question?
I think so, but I guess I was going a slightly different direction. So like, let's just pick on the fire hydrant. He's really
Sure.
lonely out there, right? So let's say AI has screened out for waterworks. There is no water facilities there.
Mm-hmm.
But your excavator has used electronic white lining and photos and has documented the proposed excavation area. The system now has the excavator's photos, which include that lonely fire hydrant. Have you experimented to see if AI can say, whoa, I screened this out, but I see that there's actually an appurtenance to something I'm screening out, so I'm not going to screen out. And I'm going to say someone has to physically go out there and locate.
So I don't think we've experimented with that yet, but that is something that we could, certainly take a look at. And it's timely because we're just now starting to run experiments on this kind of thing. So, thank you.
This is Sean from USIC. My question is, use of AI and screening. Is there a relationship between more screening is facilitated by AI, and if you screen to a certain level, then you get to a point where you start causing possible damages? So I don't know if you guys have done a study to understand screening relationship, quality of screening with AI. And the second part is, how is the accuracy of mapping, underlying data affect the AI's ability to properly screen data?
Sure. Great question. Questions. First part, absolutely there is a correlation, right? As an extreme example, if you cleared 100% of your tickets, you would have more damages, right? And so the idea here is to strike a balance, right? And our tools allow you to learn to know how to do that, right? So in this what if analysis that I spoke about, you would be able to see, just looking at historical data, that you did not take an automated action on, or even an AI augmented action on, and say, okay, if I set my automation threshold at this, I would have encountered 0 damages. If I set my automation threshold a little bit lower, oh, there's the first damage, right? And so that allows you to be informed and tune if that's what you want to do, right? And this, again, is all based on risk profile, right? A gas utility may not be amenable to this like a different kind of company is. And sorry, your second question was around the GIS data. So what we've found is that, yeah, the GIS data definitely, obviously helps, right? That's how screening has been done traditionally. The problem is that not all of that data is accurate. Some organizations' data is quite good, others is not, right? And so what we've found by analyzing millions of tickets historically, the model actually starts to build its own picture of where assets are. Because if you have tickets that have been cleared consistently in an area for 5 years, let's say 100 tickets, and 100% of them are clear, you can be pretty confident there's nothing there, right? And the same is true for the opposite, right? You can be pretty sure that something is there. And so it starts to understand this. And so the marriage of the two, right? The more deterministic approach of of here's where the organization says something is with what the model has inferred based on past experience is the maximum, where the maximum value lies. Great questions. There. Oh.
Thank you very much. Do you guys capture the locate quality as well? That's number one. Is that also in your model? I mean, you could potentially take it down to the operator level and say this person is very good and damages go up. The second thing is, are you guys partnering with design construction, either software or municipal construction groups where they have hundreds of thousands of photos, pre and post construction? In other words, are you accepting data from cities?
Currently, I'll answer your second question first. Currently, no.
The locate data is not being captured.
Do you? Maybe I'm misunderstanding.
Metadata, like the quality of the signal and that kind of thing.
So coincidentally, there is a presentation going on right now by one of my colleagues at Irth, Matt Fregale, and that is a partnership presentation with UTTO and I believe radio detection. And so to answer your question, we have not yet looked at locate quality data, but we are, that is something that's on our roadmap. So we would be able to partner with these locate wand vendors and other organizations that have field locate data. I call it the best ground truth data ever because it's literally ground truth. And so we would be able to look at that and factor in it. I think there would be a lot of predictive signal there to say, not just on a locate basis, but also on a technician basis, right?
Yeah.
So, yeah. Thanks for the question.
How long does it take, once you've implemented it, how long does it take to collect the data that's going to assess each and every ticket and give it a risk assessment?
Yeah, sure. So we actually have a foundation model for risk, and it's trained on tens of millions of tickets across a lot of North America, right? And so that's a great start. And then after, what we can do is we can use your organization's historical data to fine tune that model, right? The reason that's important is that that blended model, that foundation model, it includes all kinds of asset classes, right? Gas, fiber, electric, water, et cetera. If you're only operating in one of those asset classes, then getting your specific information included in that as fine-tuning is highly recommended, right? The other thing that we found, and we've done studies on this quantitatively, is how risk is different in different parts of the country. A lot of that can be driven by seasonality, right? Seasonality of the dig season, but also climate. And so, if you're in, say, I'll say this, we don't have any risk data in Alaska right now. So if you were operating in Alaska, your risk game there is probably different than it is here in contiguous United States, right? So that's why we highly encourage, we have great results from our foundation model, but we have significantly better results when you fine tune it based on your specific organization's data.
Wouldn't like state and local enforcement also?
Absolutely. Yeah, so the differences in laws between each states, the differences in best practices, right? Not just, on the damage prevention side, but also the difference in practices in the excavation side, right? Certainly play into that, and that's another dimension of geography that really benefits from that fine-tuning of hyper-localized data. Good question.
Yeah, the question I had would be like, you put like a time value on the scope of work, we categorize
Yeah, so that would be included in one of the things we're working on right now, which is the ticket effort and cost model. And so there were 3 things we were looking to predict there. One is the amount of footage that was marked, which can be challenging because of these large call center polygons, right? The second is service time. So how long did it take to service that ticket? We also have we're using other things like the number of site visits that were required, the number of people it was assigned to, the number of minutes that somebody looked at it on the screen, right? All of these are inputs to that model. And so we use that as a way to, and we found, so far preliminary results are looking very good, but that spike is not done yet. That would be included, yeah. So it's from the first time they set foot on site to the time that they completed the ticket. Right?
We have time for one more.
Guys, this is Ruby. Thank you for the presentation. This is really great. I actually have 2 questions, one for each one of you.
Sure.
So I'll start with the AI blueprint. Thank you for sharing that. I'm curious, where do you do the governance piece in this? Like, what step are you looking at AI governance? Before the showcase and also after the showcase, because that's going to be a continued process.
I'll let you take that.
Okay. So in terms of governance, that would be part of the data step, right? And so what we have at Irth is a data platform that has governance as a pillar, right? And so we know what our rights are around each piece of data, how it can be used, where it can go, right? If it needs to stay in, for example, Canada, it can't leave the it can't come to the United States. So all of that governance is baked in to our data plane.
And the rules and check engines would also be that.
Sorry, say that again?
The rules and the checks and balances, the rules engine is also part of your data set, or would that be a separate?
I'm not sure I understand.
Like the validation rules for when you deploy the governance.
So I'm still not sure I understand
So
that.
when you validate, like the data, you've done your governance, you've deployed you've done your AI sketch, how do you keep validating that your data is not going out of band?
I see. So that is done through networking within that data platform, right? And so the only way that it can be, first off, it's all anonymized, right? So all PII data and other sensitive data is removed from it. Second, we only expose this on an insights basis, right? So you can submit a request on, say, a locate request or something like that, and you'll get back the scores, along with explainability, right? We didn't touch on that a whole lot here, but we do have interpretability and explainability. So you can see, and we can enforce and ensure that there's no bias involved, there's fairness, and